So in the past cycle, since Austin, where there's been a leadership update, myself is David Lyle, and I work for Intel, and I'm one of the SIG co-leads now. This is Chris Hoge. I'll let him introduce himself.
Yep. Hi, everybody. I'm Chris Hoge. I'm from the OpenStack Foundation, and I've been kind of doing this OpenStack Kubernetes integration work for, I want to say like a year and a half now.
I think that's right, yeah. And then Robert Morris is the other SIG co-lead. He wasn't able to make it here for this. And then we also want to make sure we thank the Eeyore and Steven, who are the original SIG leads and kind of got the SIG going for the great work that they did. So the mission of SIG OpenStack is really to coordinate the cross-community efforts between OpenStack and Kubernetes. It's really a love story, right? But they're complementary software solutions, and there's many ways that they can integrate. So OpenStack can be run on top of Kubernetes, so we can use it to provide a scalable control and data plane. We can also run Kubernetes on top of OpenStack to provide the easier app development in a multi-tenant environment. And we can also use the service providers inside OpenStack, such as Cinder and Neutron, inside Kubernetes deployments.
Yeah, and one thing that I think is important to note about how this SIG is structured and how it works is where it's not just traditionally within the Kubernetes community, there's, SIG has ownership and, ownership of code and a mission, and that's certainly true of what we're doing here. But this is also, the Kubernetes and OpenStack are two very large open source communities. And on the OpenStack side of things, we also have a SIG Kubernetes, which is the exact same organization. The idea being that by having a special interest group that's recognized by both communities, we're able to take advantage of the resources that are available, be able to engage both of the communities in a more direct way and act, and the members of that SIG act as as kind of, ambassadors between the two communities. And so, you might hear, if you come to some OpenStack events, you might hear talking about, OpenStack SIG Kubernetes, and these are the, by design, these are the same organizations, and we welcome anybody from either community to come and participate.
This is just to give a little bit of idea of the history of the efforts inside of the OpenStack community to build this that SIG up and really get a lot of cross-pollination between the communities. And then more opportunities coming up in the near future. Yeah,
and there's, for those of you, we have KubeCon and Cloud Native Con, that's happening right now, and so we're going to have this SIG update today. On Friday, we are going to, at the end of the day, we don't have the distinction of being the last, as like one of the keynote speakers. But at the end of the day, we're going to have more of a deep dive session, and those are more of an open working session, so that anybody who's participating in the SIG or anybody who wants to participate in the SIG, we can kind of we'll work on. Looking at current work items, talking about future work items, and just kind of like a face-to-face working session for all of us to get together and work through some of the issues. And so I really encourage everybody to come to that session if you're interested in participating, or if you're currently participating and you kind of want to meet your co-collaborators face-to-face. The other thing that's happening is we're doing some Kubernetes and OpenStack leadership story trading over this week as kind of a hallway track. The first one is going to be directly after this session. So again, if that's something you're interested in participating in, please come and talk to me afterwards. So that's some exciting things that are happening there. We have over 60 sessions that are happening at the OpenStack Summit Vancouver that are devoted to container technology. A lot of that is going to be focused on Kubernetes, and so that's a fantastic event. It's going to be co-located with the Open Dev Conf, which is focused on CI and CD. I'll be at DockerCon in the middle of June, and then we'll probably have something going on with Open Infra Days in China. We have a bunch of contributors who are, who originate from China, and so I expect that we're going to have a lot of participation from community members there. And so these are kind of like, the big events that are coming up over the next few months.
Okay, so now we're going to talk about the actual code part of this for what we accomplished in 110. So there is a cloud provider in the Kubernetes repository right now. During this cycle, we created a external repository, and you can see the link for it there. So this is part of the grander effort to move all of the integrated cloud providers into their own repositories so they can better manage the code and have it a little bit more pluggable and reduce the size of the overall Kubernetes repo. So currently we have the cloud provider repo that we have now tracks the upstream Kubernetes provider code, so any changes that happen there, we pull down. In addition to that, we can land new features into the new repository. So those don't get backsynced into Kubernetes, but we can still add new features. And then we have a deprecation and removal plan at least.
Yeah. And one of the exciting things so you'll notice that the location of this repository is still within the Kubernetes organization, and you can actually go and find all of the other providers at similar addresses, cloud provider Azure or cloud provider GCP. And this is by design. There's Working Group Cloud Provider, which is working to create and kind of enforce standards across all of the providers. And so not only just behavior across the provider plugins themselves, but also what are the expectations of documentation? What are the expectations of testing? What are the and what are ways that we can collaborate so that the cloud providers aren't working in a silo and providing a different experience for everybody, but instead are working together so it makes it easier for you to transition your workloads from one cloud to another, regardless of the provider that's underneath it. And so that's another pretty big focus of our efforts, is to make sure that we remain active with the Working Group Cloud Provider, as well as SIG testing and SIG docs and I think SIG architecture, for the provider code itself, to make sure that we're providing the best experience that we can for the entire community.
Some of the additional things that happened with the provider is we've added LBAS v2 integration, both external and internal, to the being managed by the provider or not. Drivers for Cinder, as you can see up there. Other various drivers, these are actually getting hosted in the same repo. So the Flex driver and the CSI driver are being hosted in the same repo. And then the OpenStack Keystone authentication driver is also part of the same repo, and these are just tools that you can use in your deployments. Other associated fixes and improvements, routing and IPv6 improvements. Now you can actually use IPv4 and IPv6 before we couldn't. And then there was also an issue with IPv6 support, so we fixed that as well. And then there used to be an experimental way to use Keystone authentication in Kubernetes. That was part of the Kubernetes repo, and that was excised from the repo. And in favor of using the now preferred standard of webhooks for authentication providers. So now there's a Keystone webhooks provider. If you're interested in using that, there's a link there to an example of how to use that. You want to talk about this?
So one of the other big things that our initial work was focused on. So we moving the provider, creating an external repository and having that hosted within the Kubernetes organization. That was a big task, and that's done. But once you have that, you want to ensure that the code you're writing actually works. This has been a problem with the provider for some time, where we actually didn't have dedicated tests running on top of an OpenStack cloud. So the first step that we took to solving that problem is the CNCF CI/CD cross-cloud repository, that URL may have changed, so you should be careful at looking at it, looking it up. But they're pretty easy to find. They have a project which is essentially a Kubernetes installer, and it has a bunch of different code that's written that uses Terraform to deploy across different clouds, and so GCP or the Packet Cloud or IBM Cloud. And the first step was adding an OpenStack specific installer that took advantage of the OpenStack provider. And then they have a set of automated end-to-end tests that they run on top of that, and also including tests of installing other CNCF projects like Prometheus and Helm on top of that, and testing it. And so when this work landed, that meant that we're testing Kubernetes and CNCF projects on top of an OpenStack cloud, and green lights across the entire thing. And so it was our first real validation that the provider was working, and that the integrations were working, and that things were running on a nightly basis.
So efforts for the upcoming cycle, and most likely beyond that as well, but is continued work on the testing front, again with OpenLab, and making sure that we can test the external provider, and in addition to the entry provider. The documentation changes in conjunction with SIG docs about where cloud provider documentation should live. We also could use a great improvement in our documentation, right. So always an ongoing effort. Another effort that we're trying to get off the ground is cluster auto-scaling support. So a lot of the other cloud providers will support auto-scaling in a cluster, and so right now this is a work in progress, but there's a lot of folks very interested in this support. And
and I think it's worthwhile to kind of shout out to Dims and Melvin Hilsman and the OpenLab team. They've really put in a lot of effort on the end-to-end testing, and so OpenLab is a free is a free testing laboratory. If you have an open source project that is kind of focused on cloud efforts, you can take that project to the OpenLab, and they will help you set up tests so that you can run CI/CD on that. They have a node pool that they work with. It's plugged in with Zool version 3. So it's something that you should definitely check it out if you have a project that you want to run tests on, but you don't have the resources to test. They'll be able to provide it for you. And not only has that testing work, that testing work, the end-to-end testing work came out of, we started that by creating an end-to-end test within upstream Kubernetes to test Minikube. Once that test was in place, it's possible for the OpenStack provider, but all of the other providers also, to use that as an example of how to set that test up. And the main difference is you add the configuration option to enable your provider, and you have run it on your cloud, and you have your end-to-end tests running. And so that's pretty exciting. If you want to get involved, refactoring and improving the documentation is a great place to start. We have a patch up, a getting started patch, and if you went and reviewed that and you shared your own experiences, they would be greatly appreciated, so that we can provide the best documentation possible. I know that you've been working on some of the cluster auto-scaling, and so if you're interested in, if that's
volunteer,
if that's a place that you're interested in contributing to the code base, it's an interesting problem to solve, especially on OpenStack clouds, where you have such a wide variety of different clouds and different capabilities that may be available to you. And the containers white paper, we're looking at releasing that at the Vancouver OpenStack Summit. We are also actively looking for contributions there. Our next major content revision is due this Thursday, and then we're going to be spending the next few weeks polishing it. So if you want to go take a look, get an early peek at it, contribute, add some polish to it, that's the link right there to get you started.
Okay, and so now we're gonna slip into a little bit more of the OpenStack side of things. Again, this is kind of the coordination between, but just a brief update. So we talked about OpenStack on Kubernetes in the OpenStack project, or OpenStack namespace. There's OpenStack Helm, which is a solution for this. It has Loki-based images, lightweight OCI-based images. And they've done a lot of work around ironic chart integration, so a new way to do your cluster deployments using kubeadm, as well as some major third-party integrations. Magnum is a service that allows you to run cluster orchestration engines on top of OpenStack. So it not only supports Kubernetes, but Mesos and Swarm, but obviously the focus here is Kubernetes. So they've had a lot of improvements as well, additional network provider support, upgrading the version of Kubernetes that they support as well, RBAC.
And I think so. For those of you who saw the keynote this morning, when CERN was talking about they had their OpenStack cloud and they were running Kubernetes on top of it, Magnum is the way that they're running Kubernetes on it, and that 115 clusters, that number's from actually a couple months ago. I actually think that's up above 200 now. There's more than
240 in the keynote.
Yeah, independent clusters. And so, this is if you're looking for managed OpenStack, and there are a number of public OpenStack clouds. I mean, managed Kubernetes. There are a number of public OpenStack clouds that you can take advantage of that with, so that you can get up and running with the Kubernetes cluster right away. And one more thing to mention about Magnum. I just came from if you're familiar with the Kubernetes Conformance Program, it's a trademark program where if you can demonstrate that your product can deliver Kubernetes in a conformant way, where conformance is measured by passing a set of specific end-to-end tests, then you have a certified Kubernetes trademark that you can apply to your project. And so one of the things we're going to be working on for the 111 cycle is to work with the Magnum team to run the conformance tests and to make sure that we have continuous conformance testing, so that Magnum will permanently qualify for that Kubernetes certified trademark, so that you can be assured that if you use Magnum to install Kubernetes, you're getting a conformant version of it.
Also with Zune, Zune is a more direct way to communicate with or manage containers inside of OpenStack, and there's some improvements there. Near and dear to my heart is support for clear containers. That was before the announcement of Kata containers, so Kata container support will soon follow, but also some PCI pass-through for GPUs and NICs. Container networking, Courier. So Courier is a project that allows you to use OpenStack neutron-based networking in a container environment, perhaps cross Kubernetes, OpenStack, or and so trying to simplify. It's just a bridge between the networking. But again, a lot of great work to add support.
But basically, if you have a neutron network running, you can use Courier to create a network. It's essentially a network plugin to your container runtime. Your essentially your Docker runtime, so that the networks you create in Neutron are transparently available to whatever your container infrastructure is. And so it started with support for Docker, and they've worked pretty hard to make sure that they have strong support for Kubernetes. And so this is one of the ways that you can have kind of a Kubernetes cluster running and have seamless integration with an OpenStack cluster that is running VMs.
So we're continuing to want to grow the community and get people's participation from both the OpenStack side as well as the Kubernetes side. As Chris mentioned earlier, we do have the deep dive session, which is really meant to be a collaborative working session. There's not going to be a formal presentation, but there is an Etherpad where you can add your topics that you want to discuss, and we can work through that. But a lot of times it's just building support and consensus around the directions we want to take, and just getting people involved. You can also reach us on Slack and the Google group as well. And we do have bi-weekly meetings on Zoom every other Wednesday, so feel free to join. And we would love to have your participation. Thank you.
Yeah. Any questions from anyone? So the question is, do we cover bare metal as well in the paper? And yeah, there's a section that we're writing about bare metal. Bare metal is interesting from a couple of perspectives because on one hand, you know whatever you can use, you need something to install and manage your bare metal, and OpenStack Ironic can do that, and especially if you're using Ironic as a driver to OpenStack, then all of the features you have in the provider immediately become available to you. And so it's possible for you to have golden images that are Kubernetes ready that you can install, you know, and you can use some orchestration tooling along with OpenStack Ironic to bring that cluster up. You know, like, you know, kubeadmin join, for example, is a way that some people do that. And you can take advantage of the storage that's available to the bare metal cluster. You can, and it kind of behaves transparently, and so there are a few caveats with that. Like, you may not want to run Octavia load balancer because Octavia will want to bring up its own machine, which means that you're devoting an entire bare metal machine to load balancing, which you may or may not want to do. But you know the provider features can be enabled on a case-by-case basis.
What about storage?
Storage? So right, so storage is another interesting thing because the provider will it just allows for transparent storage, and so you know through the API when you request storage, it'll go to Cinder, it'll
You cannot max in the volumes to.
yeah you can do that, but the drivers, the standalone drivers, let you run Cinder on its own somewhere, and you don't need a full OpenStack cluster. You know you can be running Cinder standalone. And the Flex and the CSI drivers will handle the attachments and you know just kind of take care of that for you. And so you don't, and there's an advantage to that because right now Cinder supports over 70 storage drivers as backends, and so you can essentially take whatever storage system you have and put Cinder in front of it and know that you have a driver that just works. And so it's a very powerful abstraction layer that is available right now.
Last one. Have you thought about RWX storage for PBs? But I seen that which when I researched it's not possible yet.
So the question is, have we considered RWX storage backed by multiple writes? That question's beyond my knowledge. I don't know. Yeah, that's okay.
No idea.
Yeah, are you thinking? Is it something like Manila, where it's I don't know what the status of Manila support is. I think that the people that you would want to talk to is one of the engineers from CERN because they're an academic institution. They rely heavily on you know things like shared file stores and. Okay. Yeah. Are there any other questions?
Okay.
All right. Well,
Thank you.
we ran a little short, but so everyone gets a little bit of extra time back. Thanks for stopping by for the SIG update, and I'm happy to talk to anyone for the next 10 minutes. You know, if you have any questions you want to ask off camera.
And hope to see you Friday.